Welcome to the Weekly Space Hangout for Friday, January 29th, 2016. We've got an unspecial guested Weekly Space Hangout this week, which was too bad because our special guest was so awesome. But we've got that rescheduled for the future, and it's going to be amazing. So don't worry, hang tough. This week, we are going to be talking about the largest solar system ever seen, Elon Musk, This Week in Musk. This Week in Bezos, 12 years on Mars for opportunity, remembering Apollo 1 and Challenger disasters, a monstrous cloud re-entering our galaxy, making new stars by adopting stray cosmic gases, work beginning on NASA's other telescope, WFIRST, and a bunch of telescopes teaming up to produce the highest resolution astronomical image. And we've got an update on megastructure madness. So joining us this week, past special guest, now regular contributor, Carolyn Petersen. Carolyn?
It pays well.
The pay is outstanding. That the NASA disclosure disinfo money, right?
Oh, yeah.
To keep a conspiracy.
It's black budget. It's black budget.
The black budget, yeah. Jolene Creighton. Hello, Jolene.
Hello, everyone, and Fraser, and so on.
We've got Kimberly Cartier. Hey, Kimberly.
Hey, everyone.
We got Morgan Rehnberg. Hey, Morgan.
Hey, Fraser. Now I have to watch in the chat for my fellow hosts sniping at each other.
What?
Hey,
and we've got Dr. Paul Matt Sutter.
Hey, Fraser. And Fraser, you are always my special guest.
Aww. So we are in a brand new way of running this show, and I apologize in advance if it sucks. It's not my fault, but we used to use the Google Plus Hangout on Air to set up our events and do that, and that is now kind of getting a little bit depreciated.
Deprecated.
You know, deprecated. Yeah. Deprecated. And so what's happening now is we're using the YouTube Live, which is the new hotness, and maybe even we'll use the YouTube Gaming. I'm not really sure, but so things are a little bit different. We don't get the Q&A app anymore unless there's a way to make it go that I'm not aware of, which is too bad. So you have to, but there is a cool chat that comes with the YouTube Live. So if you want to be a part of this YouTube chat, you have to watch it on the YouTube site. I don't know. And then there's like a chat and people are talking. So that's what's happening. I apologize that you can't just like click the video wherever you watch it the way it used to work. And the other problem is I can't really see the questions too well, so we're going to try and figure that solution out. The good moderator folks for the team are going to be doing this. A big thanks to the Weekly Space Hangout crew, as always, who are like staffing the moderation of this. I really appreciate it, and stick with us. We will figure this out over the next couple of weeks and get it a lot more smoother. But hopefully, hopefully some of you got a notification that this live stream was about to happen or something. Anyway, all right, let's get on with the news. And I think the news that I want to start with is this sort of last-minute news from Kimberly that there's some kind of update, some kind of drama with the alien megastructures. Tell me more.
Yeah, scientists can be quite dramatic at times, it turns out. So I think a few weeks ago I reported that there was some anomalous activity with this alien megastructure star or Tabby star or Kick, whatever the number is, I can't remember at this moment.
Just call it the alien homeworld.
The alien megastructure star.
Yeah.
Or the WTF star, as it's colloquially known in the astronomical community. We reported that it was dimming very, very slowly over hundreds of years, and that was really interesting because nothing had ever done that before. And then earlier this week, there was a paper released on Archive that said that no, it's not dimming, or everything is dimming, and so it's just systematics, don't worry about it. And caused quite a bit of stir because they didn't actually talk with anyone who had done the original study to, confirm that their methods were right, and this was a very new method for these people. And working with old Harvard photographic plates, they're very temperamental. They're very, very difficult to figure out all of the strange things that happen with them. And apparently they missed a number of quite important systematic things, and they included bad data where they shouldn't. And so the two people who are said, yes, it's dimming, no, it's not dimming. They've been going back and forth, arguing in the sort of polite but dismissive way that academics can do sometimes. Anyway, drama. Most of the people I talk to still say it's dimming and believe the person who has spent many decades studying Harvard photographic plates over the people who haven't. So,
All right.
hey, drama.
But still no explanation for why.
Still
a star
no
might be dimming
explanation
like
why.
that. Yeah.
But I think we're getting more confident that the dimming is actually a real phenomenon. We just have no idea why. No good theories.
Maybe
That's,
the astronomer's eyesight is just getting worse.
Or maybe
Over
everything
hundreds of years.
getting
Yes.
brighter except that star. I'm trying to think here. And then we're just having trouble
Well, he's
measuring
only
it.
looking at that one star.
Yeah. It's just like burning a hole in his retina, right?
Well, actually, Bradley Schaefer posted a paper, and he's been looking at this too, and he said that there are other stars that they've looked at in the field that aren't dimming.
Mm-hmm.
So, you know, there's
They
a lot
have
of
good
detail.
comparison stars.
Yeah, yeah.
All right, so there you go. There's your update. We'll continue to bring you every single jab, every snarky Astro PH paper that comes out until we get to the bottom of this and discover that it's definitely not aliens. All right, so let's go. Let's go and talk about this week in Blue Origins.
So for the last few weeks, it's kind of been a one-upmanship between SpaceX, of course, led by billionaire Elon Musk, and Blue Origin, led by billionaire Amazon.com founder Jeff Bezos. And they've been racing to sort of claim the title of first company to successfully deploy a reusable rocket. And Blue Origin was the first to launch and land the rocket, and then SpaceX launched and landed their rocket. And now Blue Origin has taken that rocket, launched it once more, the same rocket, and landed it again once more. And they took it, they flew it up to 100 kilometers. That's the legal definition of the edge of space. And then they brought it back down for a picture-perfect landing in the center of the launch pad. And of course, this has led to much billionaire sniping back and forth on Twitter. But it's clear that these are somewhat different paths that they're on. The Blue Origin project right now falls somewhere in between the old SpaceX Grasshopper reusable rocket test program and their current Falcon 9 program, because Blue Origin isn't attempting to actually deliver any payload to space. They're going not nearly as high as the Falcon 9 goes, and they're going with a much smaller rocket, and therefore lighter rocket, than what SpaceX is trying to do. Nonetheless, this is a important breakthrough to have because we've now demonstrated that you can fire a rocket and rapidly turn it around, refurbish it, and fire it again. And that's sort of the basic competency that's going to be necessary. Once we master landing, it's going to be a question of, well, how quickly can you turn these things around and get them going again? And as Blue Origin scales up their rocketry program to orbital-sized rockets, they now have this bed to build that technology on.
Yeah, I mean, with with Jeff Bezos, I mean, he was having to like people are like, yeah, but it doesn't go to orbit, dummy. Like, you spent all that time and money and you made a rocket and it doesn't go to orbit like the SpaceX one does. And the response.
I mean, I can make a rocket that doesn't go to orbit.
Yeah, but the response to Bezos has been like, duh, we're aware that this is the first step, and now we're working on the orbital version. This is the smallest. What do you see? This is the smallest rocket we're ever going to produce. There's going to be bigger ones. They're working their way towards going orbital as well. So it's just, I don't know. It feels like the different people seem to think the difference between SpaceX and Blue Origin is like, it's like Neanderthals and modern humans, but it is not. They are a couple of years apart, and I'm sure we're going to see more and more interesting, larger capability suborbital launches. Like, what about launch in New York and then land in Los Angeles, things like that, right? So.
Yeah, these are two companies that are taking different tacks to the same end. SpaceX focused on having a workable workhorse rocket before they began expanding into some of these new technological areas, while Blue Origin wants to build from the ground up with these new technologic ideas, and ultimately end up once more with a workhorse rocket capable of delivering payloads to orbit. And for everyone involved, for SpaceX, for Blue Origin, for the American public, and for citizens around the world, having competition like this is a really, really valuable thing, because it's going to spur both of these companies to continue to push forward and sort of press the boundaries of what's possible, while also looking to reduce the costs of these launches so that more and more people can get to space. And that's a win-win for all of us.
Yeah, totally. Okay, so let's talk about This Week in Musk then, Jolene.
Okay, sorry. See, I was typing in the chat.
Yeah, you were talking to people. Just focus. Focus on the show.
Okay. So we're going to Musk, This Week in Musk.
Yeah.
Fantastic. So Elon Musk, as some of you may or may not be aware, has plans for manned missions to Mars. And the media has been talking for a long, long time about when he's going to actually come forward with something real and something tangible. And so he said today, well, not today actually, it was this week, in the coming months, we should get more information. But the reason I wanted to talk about it is because I think it's really, really interesting conversation in that what Musk says, and which I personally sort of believe as well, is that we have to get to Mars. We have to colonize other planets, or we'll perish. And of course, that's going to happen eventually anyways. I mean, it's possible we turn into some super beings and live forever. But realistically, we either colonize other worlds or we die on Earth. And I don't think that most of us want to be a species that stays on one planet and dies on this world. And so a lot of people have been sort of taking Musk to task and saying things like, we need to work on fixing problems here with sustainability, with resource allocation, and things like that. But of course, the thing to remember is that individuals, entrepreneurs, scientists, they never just work on one issue. If we had all the scientists working on one issue, we'd probably get absolutely nowhere. So there are individuals working on those things, on fixing all the problems that we've created with Earth. We also need individuals working on getting us to other planets, on space exploration and colonization, and trying to, NASA is currently working on plans. They hope to have manned missions in the 2030s. Of course, there's Mars 1, which I think has a much sooner time frame, although I can't remember off the top of my head. And there's been a lot of questions about the...
Never is not sooner than the 2030s.
Yeah. Yeah. So there's been a lot of questions about how realistic... But I do think it's notable, and it's an important conversation to have about, getting the heck off of Earth and really going out there and doing this manned exploration, seeing what the problems are so that we can modify what we know and really make these long-term colonies. So.
Nancy Atkinson did a great story on Universe Today about a week and a half ago, and she had some cool drawings that have been floating around. I don't know if you've seen these of what the Mars transporter might look like, and sort of did some more reporting on top of that. One of the things that I find really interesting is that Elon Musk has stated that SpaceX will never go public. It will always remain a private company, so that they can take the profits from selling rocket launches to NASA, et cetera, and then dump that into sending human beings to Mars, which is, no shareholder would ever buy into that, but because it's not going to be a public company, it doesn't matter. So
yeah, one of the things, because people are saying in the comments, and this is what I see all the time, like, we're going to die on Earth, like, we're doomed, look at what we've done to the planet. And historically, yes, we'll absolutely admit that we have done things without forethought, without thinking ahead. But I don't think that we can say we're absolutely going to die on this planet. We've ruined it. We are at the brink right now. I firmly believe, and what other experts and scientists and sort of the leaders in innovative technology seem to think, is we're at the precipice right now. This is the moment. These are the decades when we're going to decide whether or not we actually are going to try and get to Mars, to get to the moon and really establish colonies, or we're going to die here. But the nail's not in the coffin yet. So.
Yeah. I let's just see what happens. A couple more years, and we'll see if we're going to be able to pull this off. All right, let's move on. Carolyn, why don't you take the role as your now trusted panelist of the Weekly Space Hangout and remind everybody of some very important and sad anniversaries that happened this time every year.
Okay, well, yeah, so this week and the first part of next week are the commemorations of the Apollo 1 fire in 1967 and the Challenger explosion, which was 30 years yesterday, and then next week the loss of the Columbia shuttle. And the reason that I decided to bring this up, I mean, it's a very sad time every year, especially for those of us who've been following the space program, people going to space for 30 years or more, for more than that, 50, 60 years. I wanted to write about it and not in the way that is clickbaity, which I start seeing every year about this time with these people focusing on the grisly parts of the disaster or the conspiracy theories which always come out, about NASA's hiding something or whatever. And I always want to have people remember that this is people going to space and risking their lives. And as we were just saying a minute ago, it's, we're going to make that decision really soon. We've gotten beyond the microbe stage, okay? That's the story last week was, we're not seeing life elsewhere because it never got past microbes. Well, we've gotten past microbes. We have this extraordinary opportunity to go to space, but we also have to take the risks to do it. So Challenger stands out for me probably as the strongest memory of all of them because I was an adult when it happened. I was a preteen when Apollo happened, and at that point I was so space mad that I just couldn't believe that something like that would happen, but it did. But as Challenger, I was actually at JPL. I was working at NASA as a reporter covering the Voyager 2 Uranus encounter, and I was there with scientists, with contractors, people who really know about all this, and we're all watching this and laughing and cheering about it going off, and at 73 seconds, the room just went silent. And I have never forgotten that. And so, after that point, we're cheering. I mean, we're clapping. We're not clapping. We're not cheering anymore. We're crying. We're hugging each other. And I don't think any of us could believe it because it was so far outside of our experience. Yet all of us had heard of plane crashes and train crashes, but spacecraft doing this? I mean, it'd be like watching the Starship Enterprise crash, which of course we have, but I mean, watching something so modern and so new die. So, and for Columbia, we're watching this re-entry, which had become so commonplace, and these things are streaking across the sky. Each one of these took us outside of our common everyday lives and our perceptions of space. And we all felt like, this couldn't happen, but it was happening. So each year I write about this, and I did it on my blog, and I did it on spaceabout.com where we did stories about these people. It was the people that actually put their lives on the line and made the risks. And I write about it each year because I want us to remember the people and what they died reaching for. And it's reaching for exactly what we were just talking about, getting out there to space, to Moon, to Mars, wherever it is we're going to go. So that's why I remember it every year.
And one of the things that's quite great is there's a lot of commemoration. NASA commemorates a lot of of their names in the things that are discovered. So a lot of the place marks on Mars, which are seen by the rovers and stuff, are named. There's Columbia Hills, and there's different names.
Husband Hill,
yeah, and they name some of the rocks and the hills and these physical locations. And so you can imagine, right, this far future where we are living on Mars, and you can walk up to the top of Columbia Hills, and there will be a monument to the spacecraft and to the people who gave their lives so that this can even be possible. So
well, the cool thing is when we have people now that look at Mars every day. We have essentially webcam on Mars, right? And they're looking at it, and something is mentioned from Opportunity or Spirit or someplace with one of those names, and somebody who wasn't even alive when that happened reads that, and it's brought back to them. And I don't see any harm in that. We have to remember the past while we're moving forward into the future.
Do you think that NASA has now based on the disasters that have happened, those 3 major disasters, that NASA is really still pushing forward in terms of the exploration, or do you think that these risks have made it too risk averse these days?
Certainly they're risk averse. I mean, the people that I know in NASA who work on these things do talk about how they double think everything and triple think and quadruple think, and they don't want to do something. I don't know, though, if the mindset is, if we say we're going to send somebody to Mars and it prangs, that they're afraid that Congress is going to cut off NASA. I mean, I don't know that they're afraid of that. Possibly there's some they do, but I don't know. I do know that in the case of each one of these, they learn something from it. They learn something from the fact that, you really shouldn't be flooding a capsule full of oxygen, when there's, wiring and stuff. And they learned about how to make sure that we're not launching in certain temperatures and how we're not going to, not take off our, engineer hats and put on our management hats and launch that baby. Those sorts of things. I remember talking to people who went out and did some testing on dropping things onto wings and wind tunnels. I think that was Alan Stern who did that, and what they learned from that, and why didn't we know that sooner? It's always a case of trying to do something after the horse got out of the barn, but we learned something from it. So that's the good side. We learned something from it. Whether or not that's made them completely risk averse, you'd have to ask them. I get that sense from people, but I don't know that how far it goes.
And what do you think about the appetite for risk for, say, the American people in general?
That's a really good question. I think people like the Buck Rogers, and they don't mind paying the bucks. When something happens, we all kind of pull together as a society and say, this happened. We had 9/11. We pulled together as a society from that. And it's not just us. I mean, Russia had their mishaps, which we didn't find out about till later, but I think they commemorated that. So possibly in the commemoration we pulled together. I honestly don't have a sense of what the American public thinks about NASA. The people I talk to, they find out I'm in astronomy or something, and they want to talk about it. They're interested.
We're in a little bit of a bubble, right?
Yeah.
Yeah, I mean, I experience, just back to the 9/11 thing, I mean, I experience every time I go to the States, I definitely experience the United States collective risk aversion because of what happened with 9/11. Every time I try to enter, as a Canadian, you experience that there is a level of scrutiny and fear that, and concern and heightened awareness.
It actually happened to a lot of us who had dark hair too. My husband had black hair, and oh my God, got pulled out of line every time. Yeah.
So Jolene, I know you've got a quote from Gus.
It's a pretty famous one, so most people are probably familiar with it. But since we're talking about the risk of space flight, he said, "If we die, we want people to accept it. We are in a risky business. We hope that if anything happens to us, it will not delay the program. The conquest of space is worth the risk." And it goes on, but people often talk about, is it worth it? These astronauts, they are aware of the risks, and at least Gus was fully willing to pay that price for discovery and exploration if necessary.
It's interesting you bring that up. When I was at JPL, after a day or so, we all kind of had that day, and we were supposed to have a final press conference for Uranus Voyager, and that got canceled. So and a day or two later, then we had that final press conference. But in the meantime, people from NASA were there with us, and people were asking those of us who were reporters, and there were some educators there, would you go up? And I think every one of us said, absolutely. We knew, because we knew the Gus Grissom quote. Most of us knew that, and it's a really good one to remember. Anything that you're going to conquest after is worth the risk. And come on, we all risk money on things every day that may or may not work out. So you risk your life when you go out on the highway. So if you're going to risk it, do it for something that's going to move us forward.
Yeah, and so we know that this is, these weren't the first, and they won't be the last. That there will be more disasters as we continue the exploration of space, and yet, unless we, as you said earlier, unless we intend to die on Earth, we have to move this forward. And I think you're right. The people, the astronauts especially, they know the risks that they're facing. So
we don't stop flying because there's a crash.
All right. Well, so this year, this time every year, I mean, unfortunately, all of these events all happen around the same time. So it's kind of like you have this barrage of memories and stuff. I can remember where I was. I wasn't alive for the Apollo 1, but I can remember where I was for the other two events, and it was sad. Let's move on now to a more sciencey note, an astronomy-related note. Paul, which one do you want to go with?
Let's do WFIRST.
Okay.
NASA's other telescope. Everyone's all talking about JWST, but you know what? NASA has plans past JWST, and I should explain the name of WFIRST because it's kind of a stupid name. It stands for Wide Field Infrared Survey Telescope, but the name comes from something else. It's actually kind of an astronomy joke. One of the main missions of WFIRST is to characterize and understand dark energy. And cosmologists, when we're talking about dark energy, we try to model the evolution of dark energy. We're wondering, has dark energy been constant all through time, and what is its current value today? And the variables we use in our equations to describe the evolution of dark energy are W. W sub 0 for the present value, and then W sub A for the slope of the time varying of dark energy. So this is a mission that's trying to get dark energy, trying to parameterize it using this W variable that we just use in the literature, hence WFIRST. So there you go. Now you know why it has that kind of ridiculous name. So WFIRST, they are finalizing the design right now. So JWST is being assembled right now and very nearly being done. The next thing to be built is going to be WFIRST. So before it can be built, they have to figure out exactly what are going to be the design parameters for the mission. And WFIRST almost didn't happen. It almost wasn't even going to fly. This was a mission that was proposed something like 15 years ago. But it got canned because of budget issues, and then a spy agency, the National Reconnaissance Office, called up NASA and said, hey, we have 2 extra spy satellites. Do you want them? We don't need them anymore, I guess. And NASA's like, yeah, sure, it's actually way more powerful than anything we have. We'll take them.
Also, this is a little creepy how powerful these ground-observing telescopes are that you just had kicking. Like, these are the leftovers.
Exactly. Like, these are like the last generation of spy satellite mirrors. They're like, yeah, these are extra
Hubble Space Telescopes kicking around that we've had all the time, and we don't really want them because they're such garbage.
Exactly. Yeah. And actually, this makes it a little bit sticky. Some of the people working on WFIRST, some of the top project leaders, they actually had to get top secret clearance and things like that because they were learning about design specifications of these mirrors that were donated to NASA before it was officially made public. Mm-hmm. And so still they can't talk about certain aspects of certain technical aspects of the mission because it's still under clearance.
That's crazy. But still, what a better use to look out into space and not look down.
Yeah, let's just turn those telescopes around.
Yeah, let's turn all the telescopes around.
Let's turn all the telescopes around.
Yeah. The most powerful telescopes, let's have them look at space instead of us.
Exactly.
Awesome. So will we finally know what dark energy is?
Probably not.
Okay.
But it'll be one step closer.
If you right now had to place your bets, what is dark energy?
What is dark energy?
Yeah.
Oh,
place your bets. What's?
Yeah,
I mean,
it's
not
actually one of those things I can't even bet on it because all the options are really, really bad.
Right. Okay. That's it. That's all you've got. That's
all I've got.
Come on.
That's all I've got. That's all. I'm not going to put money on the table.
That you think sounds a little more likely than the others.
Okay. So the only reason I'll go in this direction is I happen to do a little bit of research on it, where dark energy is a new kind of field that permeates the universe and that interacts with dark matter, but not normal matter, and they kind of evolve in lockstep. They're coupled. This allows you to have cool things like extra forces of nature that only happen among the dark matter, don't happen to normal matter, and it slightly affects the evolution of the universe. And it explains why it has the value it does, why the amount of dark energy is roughly the amount of dark matter in the universe is because they're coupled to each other.
Whoa. Daniel Meeks in the chat says it's midichlorians. Do you think maybe midichlorians is a good answer too?
You know what? It's just about as good as any other guess.
Yeah. All right.
Midi-chlorians are never the answer.
Evil Nine says the internet.
Except for dark energy.
William Van de Beek says decayed photons. So there's some. Look at me watching the chat at the same time.
Nice.
All right, let's move on.
We're so distracted now.
I know it's totally. This chat is the devil. I've kind of missed the people who are watching the show after the fact, and they're missing this really awesome conversation.
Well, you should tune in live.
You really should. Yeah,
that's the way to watch.
At the end of the day, that is the thing. The lesson that we've learned is that if you want to really experience the show and all of its true awesomeness, come on over here and chat with all of the guests. Although they're a little distracted. All right, Morgan. No, Kimberly, let's do one of your actual stories. So why don't we do the Monstrous Cloud Boomerang back to our galaxy?
Sure. So astronomers have known for a while there's this very large gas cloud that exists outside the Milky Way. It's called the Smith Cloud in the direction of constellation Aquila. It's a very large cloud. It was detected back in the 50s, I think. And it's a very strange thing, this cloud. It has no stars in it. It has nothing that would suggest that it was a galaxy or anything like that, but we have no idea where it came from. And it's on a collision course with the Milky Way. It should get here in about 30 million years. So naturally, we're kind of curious what this thing is. And new evidence shows that this cloud might actually have originated in the Milky Way itself, was somehow flung out into intergalactic space, and is now making its way back to us. Now, we have no idea how on Earth it would get out, what on Earth made it leave, but it's certainly an interesting phenomenon. We think it came from the Milky Way based on the composition of the cloud itself, which was measured by looking at the light from 3 very distant quasars. Very, very distant quasars. As the light passed through the cloud, we were able to get composition of the cloud, and it very closely matches the composition of the outer Milky Way. And it doesn't. If it were if it were a cloud that was just floating around intergalactic space until it wandered too close to us or something, it would not have quite as many heavier elements as it does. It shows that the gas came from a part of space that had a lot of star formation because it has lots of very heavy elements that are only made in stars. So now the question is, what kind of mechanism could cause this very, very large cloud to be flung out of the Milky Way's considerable gravity well and then cause it to turn around and come back? So we have no idea. There are a couple of really...
Were you asking me?
Well, who the heck knows? If you have
Fraser,
a good
what
theory,
you got?
Okay,
Now
so
it's
I'm
your
going to
turn.
guess a three-body interaction with the supermassive black hole at the heart of the Milky Way. I'm going to go with a small galaxy that was torn apart through tidal
well, it can't be a
forces.
small galaxy because there's no stars and no evidence of star formation.
Well, they could have been
So I'm gonna
stripped
throw that one
out.
out.
Could have been stripped away. Could have just been a primordial gas cloud that's been in orbit around the Milky Way and then just sort of, we're just
I also
seeing
had
it
to
on its
debunk the
orbit.
primordial gas cloud. There's too many metals for it to be left over from the creation of the universe.
I got nothing else.
One
I
of
got
the
nothing
interesting theories that was tossed about was that it was actually started out as a stray clump of dark matter that had no luminous matter attached, that flew through the Milky Way and snagged a bunch of material on its way through. Which, there's absolutely no way that we could prove that. But it was one of the more interesting theories that I saw.
The article that's getting shared around on Reddit is one from, I think it's The Independent, which says that, I think they got it wrong, well, they definitely got it wrong in the title, that when it arrives, the galaxy could trigger the birth of 200 million stars. The article actually says 2 million stars, and that's sort of what other media sites are reporting. But is there going to be this massive explosion of stars, or is that not?
There could very well be. We see a lot of times in the distant universe when two galaxies collide, it's really, the stars aren't colliding, it's really the large clouds of gas that collide. And when you get a lot of star-forming material that collides and compresses together that very often does trigger a very large burst of star formation all at the same time. And that's exactly what this cloud is going to end up doing to the Milky Way. It's a very large cloud of gas. The Milky Way disk itself has a lot of gas in it, and so when the two forces combine, they're going to produce quite a lot of stars.
So we're going to have like tons of new neighbors, is what you're saying. And probably
Tons of new neighbors.
Aliens. Awesome.
Yep. That'll be great.
You know, actually, there's a story coming out real soon, Kimberly, from the Subaru telescope, where they did actually do some tracers of starburst knots and how they formed in the collision of two galaxies.
Oh,
so
nice.
I'm going to keep an eye out for that.
I will
The other
keep an
thing
eye out
is,
for that, yeah.
there's another story out there floating around about this thing that you guys read Gizmodo.
No,
Yeah.
not so much.
Well, they're basically calling it the cosmic fart cloud. There's if you want the link, I'm happy to give it to
I
you.
didn't even go there, but that's right.
No.
Here, I'll give you the link.
Oh, yeah, hydrogen with heavy metals. Totally the cosmic fart cloud.
Oh, I can't do
Well,
that.
astronomers are really terrible at naming things, so you
Yeah.
know we.
Yeah.
Yeah, we'll let it go with that.
Just
And
search on fart
2
cloud.
million stars. Okay. To get
Yeah,
away
that's
from
a lot.
farts,
Yeah.
2 million stars sounds like a lot, but it's like 0.1% of the population of stars in the
Yeah,
Milky Way.
mhm.
Yeah.
0.01%. It's not much.
I thought it said that some people were saying, I didn't actually read the paper, but that it had a mass of 2 million stars. So if it has a mass of 2 million stars, it's probably not going to trigger the birth of 2 million stars. But as I said, I didn't read the paper, so I don't.
I think you're right, though. Yeah.
All right, well, let's move on, because now we're just starting to just make stuff up, I think. Jolene, let's talk about the largest solar system. This is so cool.
Yes, it is. And talk about bad names for things. I'm going to refer to it as 2MASS because it actually is 2MASS with a whole bunch of numbers after it. But basically, astronomers found these two objects, and they happened to notice that they were the same distance from Earth. So they thought, hey, we should look at these two things together. And when they did, they found that they were actually following the same path. So they found that they were in orbit, or rather this planet, 2MASS, which is about 12 to 15 times the size of Jupiter. So a huge gas giant bordering on brown dwarf, probably, is orbiting around a red dwarf star, and it's orbiting at about a distance of 1 trillion miles. I think it takes about 1 million years. It's actually 900,000, but somewhere between 900,000 and 1 million Earth years to complete one orbit around the star. So that's just how far away it is. For comparison, Pluto is 5.9 billion years, or sorry, 5.9 billion kilometers, not years, from the sun. And it took New Horizons a decade to get there. And this planet is 1 trillion kilometers from its sun. So, I mean, traveling, if you were at any planet, closer in, it would just take you forever. You'd basically never be able to explore that world. Another comparison is it takes light from the sun 8 minutes to reach Earth. It takes light a month to get from the red dwarf out to 2MASS. So the distances that we're talking about are just absolutely absurd. And one of the things that the authors of the paper note is that because they're so far away, it's highly unlikely that the pair formed in any way similar to our own solar system. So what they currently think is that they're part of the same enormous filament, and they later got pushed together and sort of started their little dance in that way.
Well, wait a minute here. So how does that compare to the mysterious Planet 9?
Yes.
What's the distance, I wonder?
We got, so how far out is Planet 9? Oh, gosh. I don't remember now.
Several hundred astronomical units, somewhere between 200 and 1,200, depending on where it is.
Isn't this like 8,000 astronomical units? I forget what the number is. It's enormous.
6,900 astronomical units away. And so I'm actually glad you mentioned it, because I want to talk about Planet 9, because on all the articles that I saw, certainly our own, people were going on and on about how this find is ridiculous and probably just a bunch of bunk, because we couldn't even detect Planet 9, the supposed planet that's in the outer reaches of our solar system, which we think is there because of the orbits of a number of different objects in the outer solar system. So what their argument is, we can't find this planet in our own solar system, so how can we find this planet that is so far away from our own? Well, and the way that that works, as we talked about last week, is there's a number of different reasons that the planet in the outer solar system might not be giving off a lot of light, so it'd be very, very hard to image. Also, as I think maybe Kimberly, I can't remember who said it now, but someone was pointing out that it's very likely that we have actually imaged Planet 9. We just don't know that it's a planet because it's moving so very slowly. We don't register it, so we don't see that it's actually in our own solar system.
Well, there have been infrared surveys looking for planets in the outer parts of our solar system based on their heat signatures. So they have a different infrared spectrum than stars do. And I believe that itself has ruled out a large part of where this planet could be. So if Planet 9 existed and was in the closer part of its orbit, if it was within 1 or 200 AU, we would have seen it already in the infrared surveys. So if it exists, it's in the outer part of its orbit below the detection threshold of the surveys we've already done.
And then hopefully new observatories, we talked about this last week, some of the new observatories coming online will give us a much better chance of catching something like this. All right, Paul, I know your laptop is about to leave us, and so why don't you kick in one last story before you run out?
Yeah, sorry about that. The spirit is willing, but the battery is weak. So I have to take off. I had one other quick little story where some radio astronomers tied together multiple radio telescopes, including one in space. And this is a special cool trick you can do in the radio, especially easily, where essentially you're building a telescope that's as wide as the planet Earth and even wider if you include orbiting radio telescopes or radio antenna. And you can do a cool trick to mesh all the information together in a very neat way, and you can make incredibly high-resolution images. And astronomers they observed what are called an active galactic nucleus, which is stuff piling onto a central supermassive black hole and then getting wound around and then spud out. Is that a word? What's the past tense? Spat out.
Spun out.
Yeah.
Either spun out or spat out, but definitely not.
I see.
Yeah, I like spud out though.
Spud out.
The poles of the black hole making these incredibly long jets that glow in radio, and we can actually detect their radio emission. So they built this incredibly high-resolution image of the system, which help us determine the astrophysics of what exactly is going on around these black holes.
Awesome.
All right.
Paul, I can do a great job of promoting you if you want, but before you go, why don't you just let everyone know where they can find out more about what you do? And
yeah, you can follow me on Twitter and Facebook. My name is Paul Matt Sutter, M-A-T-T, and then S-U, 2 T's again, then E-R. You can also go to pmsutter.com. That's anytime I'm in the media or doing something, I put a link on my website. So that's a great repository of information. And if you can also listen to my podcast, which is askaspaceman.com, and you can help support it at patreon.com/pmsutter.
And you'll need to sign up to his podcast because there's going to be a very special crossover episode between the Guide to Space and the Ask a Spaceman. So
I'm excited.
You'll need to connect to both to get the full story. Otherwise,
I would watch it. I would watch it.
Absolutely, both halves, or else either one doesn't stand alone. But together, if you subscribe to both, you'll be.
We are
able
the
to
Voltron of space news.
All right, take that, put that battery out of its misery. Thanks, Paul. We'll see you later.
Thank you, guys. See ya.
All right, we got a couple more stories, which is great. I gotta say, it's kind of nice to be able to work through all of the stories with leisure and time. Let's move on to 12 years on Mars for Opportunity.
Yeah, I got the happy anniversary
this
episode because 12 years ago this week, the Spirit and Opportunity rovers touched down on Mars, and Opportunity has now been going for that entire 12-year period. You might recall that its original mission was only 3 months long, and so we're nearing 50 times its designed mission duration. And over that period, Opportunity has driven nearly 43 kilometers, whilst taking more than 207,000 pictures of the surface of Mars. And in its elderly years, it's not at all slowing up in terms of the science that it's doing. For the last few months, Opportunity has spent exploring an area of Mars known as Marathon Valley. Mm-hmm. And Marathon Valley is particularly geologically interesting because it's different than anything that Spirit or Opportunity had seen before. It's different than anything that Curiosity has seen before in terms of its geologic formations. And one of the things that led them to visit Marathon Valley was the location of a mineral called smectite. And smectite is a clay mineral that was actually observed by orbiting spacecraft around Mars, and then they redirected Opportunity to go over and check that out. And what's interesting and important about smectite is that it only forms in the presence of liquid water, and it only forms in environments that aren't extremely acidic. And these are sort of two of the keys we need if we're talking about looking for life on early Mars. We now have myriad evidence that there was water on Mars for long periods of time in the far past, but in many regions it seems like that water could have been quite acidic. And acid is not so great if you're looking to form or sustain life. But here in Marathon Valley, what we see are evidence of water persisting on the surface long enough to form these large clay deposits that would have been much more hospitable to life somewhere around 4 billion years ago.
How much longer is Opportunity expected to last? Do you think it's like, because I mean we saw Spirit die slowly, and wheels went, and it started to have some problems with its computer. What's going to take out Opportunity at this point?
So it's a question of luck at this point. As all of its components age, really anything could go at any time and take it down. And what happened ultimately to Spirit was that the wheels began to break down. And that wasn't immediately harmful to it, but it meant that it eventually got stuck in a sand dune. And its solar panels were facing the wrong direction. And when winter came, it froze to death. And so it's quite possible that that could eventually happen to Opportunity. This sort of the slow accumulation of physical breakdowns doesn't kill it sort of in one death blow, but it makes it more and more likely that it'll find itself in a situation where previously it could have escaped and continued on, but this time will end it. The other possibility is that it gets killed off in a NASA budget, and they just stop using it. And this has been something that it's been in danger of for the last several years. Because it's so far past its planned mission duration, and we have a more advanced asset on Mars now, several times over the last few years, it's been targeted for elimination in one or more of the various budgets released. And thus far, including in 2016, it's avoided any sort of risk of that happening. But if NASA's budget were to tighten up again going into 2017 or beyond, then you might see Opportunity on the chopping block once more.
So just a couple comments. Thomas Traniker says that Opportunity's been working 432 times longer than expected, which is crazy. That's got to be a record. Although, they probably picked that initial 3 months just giggling to themselves. Like, how long is it going to work? I don't know, 3 months maybe? But they knew it was going to work longer because it's got the solar panels. Gman351 says, are these rovers radioactive? They're not. Spirit and Opportunity weren't. They're solar panel powered, but Curiosity is the one that has the RTG.
That's right, and that's actually what they thought initially would probably be the downfall of Spirit and Opportunity, is they weren't so much concerned about it from a mechanical standpoint, but they were concerned that buildup of dust, that red Martian dust on the surface of the solar panels, would eventually cut down their power production to the point at which the instruments and the computers and stuff would no longer have enough power. But what they discovered when they landed was that the wind and windstorms on Mars were far more active than previously thought, and that wind blows off the dust off the solar panels sufficiently to allow enough power generation to go through, even in the coldest parts of winter, which is what what Opportunity just went through.
Yeah. Okay, I think we have time for one last story. Kimberly.
Yes, so this last story concerns one of the most fascinating objects in outer space, except for exoplanets, in my humble opinion, which are globular clusters. Globular clusters are large, dense clusters of stars, about 1,000 stars or more. There are hundreds of them in the Milky Way alone, and they can be some of the oldest gravitational groups in the Milky Way. There's always been a bit of a mystery surrounding globular clusters, because for these kinds of objects, we always previously thought that all of the stars in the globular clusters formed at the exact same time, as the large gas cloud collapsed, and all the stars were triggered all at the same time. And then we didn't think that there could be another epoch of star formation in these globular clusters, because as the largest stars will go supernova, they would blow out any remaining star-forming material very early on in the globular cluster's life. So it came as a real shock to us when we started getting more accurate ages of these globular clusters and saw that these stars actually came from not one, but two or sometimes three different epochs of star formation. And that really shouldn't have happened. But there was a theory proposed back in the 1950s or so that says, well, these globular clusters, they're not traveling through empty space. They're traveling through the Milky Way, which has lots of gas and dust and lovely star-forming material that these globular clusters really need. So as they're traveling through space, they probably pick some of that up, and some turbulent motion could trigger more star formation. Sure, why not? But 50, 60 years went by, and there was no evidence to support this kind of extra star formation until very recently, when a group of astronomers were studying some younger globular clusters in the Large and Small Magellanic Clouds, and found that the ages of the different epochs of star formation actually lined up rather well with the globular clusters slowly accumulating gas and dust as they traveled through the Magellanic Clouds. So it's actually it's a compelling theory, because we want to use globular clusters for things like age dating of the Milky Way and age dating of other star clusters that are perhaps a bit more difficult to get ages on. We use globular clusters as benchmarks, and so we really want to understand them and figure out why the stars are different ages when they really shouldn't be. So this is sort of
a mysteries with globular clusters is that they appear in some cases older than the universe itself. Right?
Yeah, and that's no good. We shouldn't have that. But this is sort of a good first step towards trying to solve this strange globular cluster age mystery. Perhaps not 100% solved, but it's a step in the right direction, I would say.
Does that help in any way, do you think? Like, one of the searches that people are doing is for these intermediate mass black holes, and the place they're looking are in these globular clusters. Do you think, the way they form, the way they come together, does that maybe change the chances of finding black holes in them? I know this isn't necessarily your field. If it doesn't have alien megastructures, you're not interested. But
one day, Fraser.
Yeah.
One day.
One day. Or is it a place we should be looking for alien megastructures? Yes. Right. I know the answer to that question.
Well, I would say that the chances of finding intermediate mass black holes in these globular clusters certainly hasn't gone down at all. I'm certainly not an expert on how you form such intermediate mass black holes. But the globular clusters, those stars, their ages are what they are, and we've known that, and we're just trying to figure out why it is. So I would certainly say that the chances haven't gone down, but we might be able to more accurately predict where we might find them.
Yeah, I mean, they're such great places to look for all kinds of things. They're where you go to see if stars can actually collide.
Yeah.
Stragglers, which is really interesting, and it is possibly a place to best look for. I know some people propose that they're some of the best places to maybe look for life and maybe look for signals, because
there was a story about that a couple weeks ago.
Yeah, you've got this density of stars and this sort of richness of raw ingredients for what life may require. So
it's also a compelling place actually to look for habitable zone planets and to have a higher probability of finding life, specifically because there's no ongoing star formation. There's no harmful radiation from supernovae or anything like that, and they're generally relatively stable environments that might actually be good for hosting life.
Can you imagine being on a world in a globular cluster and what the night sky would look like? It would just be
absolutely fabulous.
It was
Well,
just
Isaac Asimov wrote that.
I know. Nightfall.
Yeah, Nightfall.
Yeah. What a great book. So I guess we should just read the book and then imagine. So why don't we wrap things up? So before we do, I want to make a big thanks to the good folks from the WSH crew, the Weekly Space Hangout crew. These are the fans, really the producers of this show, who really make everything happen. They organize our guests. We have guests all the way through till April now. A big thanks to Nancy Graziano and the rest of the team. And I'm going to remind or let the people know in the chat right now to go ahead and post some links to places where people can go and find out more about the WSH crew, both the Twitter handle, the website, there's a Google Plus community, and link it up. And then people will be able to join the crew. And so it's like if you want to get to the next level, if you love the space news, that's great. But if you actually want to sort of talk with the fans, and like I said, these are not the fans, these are the producers. They just tell us what to do. We just show up. They tell us what to talk about. They tell us who our guests are going to be. And it is, we are trying to really sort of allow you to help us make the show that you want to see. And so this is a way to do it. So let's give everyone a chance to find out where we can find out more about them. Carolyn, where do people find out more about you and what you're working on?
You can find out about me at thespacewriter.com. One word, thespacewriter.com. I'm the Space Writer on Facebook, and you can talk to me on Twitter at @spacewriter.
Perfect. Jolene.
You can find me at futurism.com, at futurism on Twitter, Facebook, Instagram, Imager, and pretty much all social media ever. Except not MySpace, not MySpace.
And speaking of crossovers, we're going to be doing a crossover with Universe Today and Futurism shortly, somewhere, somehow.
Yes, I emailed you. You haven't gotten back to me yet. We're on.
It's going to happen. Yeah. Awesome. Kimberly, where do people find out more?
People can follow me on Twitter at AstroKimCartier or check out my website, www.kimberlycartier.org.
Last but not least, Morgan Rehnberg.
Well, you can come out to Fisk Planetarium if you're in the Denver area tonight and check out our latest show, It's About Time, exploring the rhythmic natures of the universe. Otherwise, you can follow me on Twitter at Morgan Rehnberg or visit my website, morganrehnberg.com.
That is awesome. So just want to make everyone remember they need to go and follow all of these people on all their social medias. They need to participate on their Patreon campaigns. We'll wait while you get that done. Okay, because you already have. So if you haven't already, make sure you subscribe to this channel. I'm on Twitter, publisher of Universe Today. I highly recommend you check out our Instagram page. We're having a lot of fun on Instagram right now, posting really pretty pictures and then writing little articles that go along with them. So check that out if you haven't, Universe Today on Instagram. New Guide to Space video on Monday, so we're back in operations, and they're got a whole bunch in the can, so should be back in business starting on Monday. So, all right. Well, thanks everyone for joining us. Thanks for the panelists for bringing the news. Thanks for everyone putting up with us dealing with new technology. I will see you all next week.
Bye.